Objective, I will be able to identify, interpret, and use important details of graphs of quadratics. The graph of a quadratic is a U-shaped curve called a parabola. Taking a look at example 1, it says that what we want to do is label each of the following on the graph. Number 1, label the minimum or maximum. So minimum is the lowest point on the graph, maximum is the highest point on the graph. So looking at this graph right here, I would say that this is a minimum. Number 2, you are going to label your vertex. Vertex is just a fancy way of saying the highest or lowest point on a graph, which also happens to be your max or your min. So a minimum can also be called a vertex. Number 3, we are going to label what's called an axis of symmetry. So your axis of symmetry is usually represented with a dashed vertical line. So I like to put AOS for axis of symmetry. This is the line that makes the parabola cut in half, or makes the points reflected about each other. Your axis of symmetry will always pass through your vertex. Next, what we're going to do is highlight in one color where the graph is increasing and in another color where it's decreasing. So in blue, I'm going to show you where my function is increasing. So from the vertex, increasing would be going up, okay? So from the vertex, I see that this side is going up. Now approaching the vertex, I see this side's going down. It's decreasing, hitting that minimum, then going up. So my left-hand side is going to be the side that is decreasing, right there. Do keep in mind it does go on forever, so it comes down all the way down, stops here, and then continues to go up. Now we're going to state the domain and the range at the bottom, so we're going to write it right here. Domain of any parabola will be all real numbers, which is also written as negative infinity to positive infinity. Do keep in mind that domain must be left to right. Negative infinity is the negative x-axis, positive infinity comes from the positive x-axis. Now range. Range will never be all real numbers because of your max or your min. So range is going to be down to up. That's always true. Maybe write a little note to yourself. Down to up. The lowest this graph ever goes, can't quite tell. It looks about to be maybe negative 6.2. It's not quite 6.5. It's a bit more, or a bit less than that. Now from this lowest point, which I did put a bracket because it's included, it does go up forever. So that's positive infinity with a parentheses. The on your own is for you to try. So I'm going to go ahead and skip that one and focus on vocab. Minimum. It is the lowest point of the graph, the smallest y value. Maximum is the highest point of the graph, the largest y value. Oops, I forgot to write those down. For example, this is a minimum because it's the lowest. This is a maximum because it is the highest. Vertex. The max, which is the highest, or the min, which is the lowest coordinate of the parabola. For example, this was a maximum, so we could have also called it our vertex. This was a minimum, which we also labeled our vertex. Axis of symmetry. Axis of symmetry is the vertical line that goes through the vertex of a parabola. For example, the axis of symmetry will always pass through your vertex. So in this on your own that you should have tried, I can see it's located at this vertical line. We would write axis of symmetry at, and you would actually tell me the line. It's always x equals a number. So in this case, it was at x equals -2. So where it says example, I want you to write x equals a number. Your vertex is usually a point. I forgot to mention that. So if I'm looking here, I would say that my vertex is located at this coordinate. That coordinate happens to be located at -2, 9. Make sure you always put your x value first, your y value second when you're doing a coordinate. Increasing. As the x value increases or moves right, the y value, well, I'll say y values, are increasing in value or moves up. Decreasing is as the x values increase, moves right, the y value, the y values are decreasing. In value going down. Domain, all of the possible x values, I want you to say left to right. Range is all of the possible y values. I want you to make a note down to up. So we already did domain and range here. Here, we did say domain is always going to be all real numbers for parabolas because of that U-shaped curve. Now this one, the range, down to up. It's going down forever, so that would be -infinity with the parentheses first. Up, the highest it ever goes is 9 with a bracket because it's included. Okay, next we are actually going to graph a quadratic function. You can use a table to help you if you like. We're also going to be identifying key details. So when I take a look at this is a quadratic equation. I can tell because it's a power of 2, so it's quadratic, which means it's going to have that U-shaped curve. Now your parabola can open up, your parabola can also open down. To determine that, you always need to look at your a value. So in this case, a is -1. Remember, negative a values causes a reflection, so that means my parabola is going to open down. Positive a would open up. So I'm already envisioning, hey, my parabola is going to open down, which means it's going to have a maximum for my vertex. You could also use parent functions, transformations. So I see there's no h, but there is a k being 4. Keep in mind, if your parent functions pass through the point 0, 0, and 1, 1, you would then move it up 4 and reflect it. Now, if you don't want to use all those transformations, you could make a table like it said. With the table, you would pick different values. So like, let's say -2, -1, 0, 1, and 2. And you could just plug it into your equation. So -2 being squared plus 4. And then you could do -1 squared plus 4, -0 squared plus 4, -1 squared plus 4, -2 squared plus 4. And you can plug that into your calculator. If you do, make sure you put your negative values in parentheses. This gives you -4 plus 4, which is 0, -1 plus 4, which is 3, -0 plus 4, which is 4, -1 plus 4, which is 3, -4 plus 4, which is 0. So if I plot those points, -2, 0, -1, 3, so -1, 3 is right here, 0, 4, 1, 3, and then 2, 0 right here. That's enough points for me to get the shape of the function. Now, this is a parabola where the vertex is right here. That's my maximum. Your maximum is the vertex. Okay, so maximum. And your vertex is a coordinate. So let's write the coordinate for that. It's located at 0, 4. Your axis of symmetry will always pass through the vertex. Think of it as the line that's cutting your parabola in half. Now, it's always going to be x equals a number since it's a vertical line. So it's located at x equals, it's passing through the x value of 0. So it will always be x equals this number right here. Domain. Domain is always going to be all real numbers for any parabola. Range down to up. It's going down forever, so negative infinity. And then the highest it ever goes, because of this maximum, is at 4 for the y value, which I would put a bracket. Increasing, decreasing. So it's going to be, as the x values increase, what are the y values doing? As the x values increase, this is going up. So the left-hand side is increasing. As the x values increase, the y values are going down on this right-hand side. I do want to talk about one more thing. Anytime you have an a value of positive 1 or negative 1, it will behave like the parent function. So the pattern here is to get from one point to the next. Right 1, down 1, because a was negative. Right 1, down 3. The next one would be right 1, down 5. 1, 2, 3, 4, 5. Then it would be right 1, down 7. So going down 1, 3, 5. Then you'll do it again, and it'll go down 7, 9. There's a pattern here. You're always going right 1, and then down, since it was negative, odd numbers. That pattern comes into play later in other notes. So I just wanted to point that out. Let's take a look here. So once again, when I'm looking at this, I see it's a quadratic because there's a power of 2. I do notice that a is a positive 1. What does that mean? Because it's positive, my parabola is going to open up. The other thing that I know, because a is 1, so there's no stretch, there's no compression, it will have that pattern I was just talking about. So it's going to go right 1. This time, since it's positive, it'll go up 1. Right 1, up 3. Right 1, up 5. Now, this is in standard form, so I'm not able to determine a, h, and k. I do have to do the table for this one. You can pick any values. I usually just pick -2, -1, 0, 1, and 2. I could have picked -5, -6, -7, 4, 8, any numbers. I just think these are really easy to work with. When you plug them in, make sure you put your negative numbers in parentheses. So you're plugging them in wherever you see x. One more second, and then we'll solve them. Okay, so -2 being squared is actually a positive 4. So I have 4 plus 4 when you multiply. That gives me 8. So -2, 8 is my first point. -1 squared is 1, and then when you multiply here, you get a positive 2. So 1 plus 2 is 3. So -1, 3 is right here. 0 squared is 0 minus, that would become 0. So 0 minus 0 is 0. Okay, now I have 1 squared, which is 1 minus 2. So 1 minus 2 is -1. So 1, -1. And then I have 2 squared, which is 4. 4 minus 4 is 0. So here. Now, plotting those points, this is what I get. I can see the shape of the parabola happening. So remember that pattern. Right 1, up 1. Right 1, up 3. Right 1, up 5. This is half of the parabola. So my axis of symmetry, it looks like it's passing through at x equals 1. I can use this axis of symmetry to help me plot the other points. So this was left 1 from the axis. This is right 1. This is left 2. This will be right 2. This is left 3. It could be right 3. So you can use your axis of symmetry to plot more points and draw a nice clean graph as opposed to keep doing a table, which I like. So my vertex is a coordinate. It's located right here at my minimum, my lowest point right here. And that coordinate seems to be located at 1, -1. Domain, all real numbers. Range, down to up. -1 for the y value, up forever, positive infinity. Real quick, the right hand side is increasing, the left hand side is decreasing this time, if you look at that.